Hello and hey class. So today we are going to be talking about different parts of expressions and collecting like terms. So the goal of today's class is to identify different parts of an expression and to combine like terms. Oops, here. Combine. So let's look at something that we've looked at before, a mathematical expression right here. You notice that there are different parts to the mathematical expression. See here the parts right here in red. Whoops. Right here in red, we have the parts that have the x's. We have a 7x right here. We have a negative 5x right here. We have a 4x. These part of the terms are what we call the variable terms. I'm going to list them right here for you. The variable terms is 7x, negative 5x, and 4x. So the variable terms of this expression are just the terms with the variables. In this case, it's x. The other part of the expression that we have here in, let's do, I don't know, blue, are the numbers that don't have any x's. So we have 3, 8, and negative 1. So let's write them right here. These are what we call the constant terms because they don't have any variables with them. So we have 3, negative 8, and negative 1. I'm sorry, positive 8. Notice how the constant terms and the variable terms, the signs are what's in front of the numbers. And if there isn't a sign, like right here on 7x, we say that that's a positive 7x. And right here there's a negative 5x. Now, there's one more type of number that you want to be on the lookout for. And we're going to circle this in purple. And this is what we call the coefficients. The coefficients are the numbers that are next to the variables. So right here, the coefficient for 7x is just the 7. And the coefficient for negative 5x is negative 5. And the coefficient for 4x is positive 4. I'm going to write these right here in this text box. So the coefficients, once again, is 7, negative 5, and 4. So the variable terms are the terms that have the x's, 7x, negative 5x, and 4x. The coefficients of the variable terms are just the numbers, 7, negative 5, and 4. And the constant terms are the terms without the variable. I'll give you a second to write that down. So we're going to try something called combining like terms. What we're going to do is we are going to simplify an expression by collecting terms that are similar to each other. This means that we're going to combine common variable terms and constant terms. So let's look at an example. Here we have 7x plus 3 minus 5x plus 8 plus 4x minus 1. So my first question I want to ask is, how many x's do we have? Well, right here we have 7 of them. Then we subtracted 5 of them. And then we added 4 x's. Well, 7x minus 5x is 2x. And 2x plus 4x is 6x. So all together we have 6 x's. Well, then the next question is how many constants do we have? And remember, the constants are the numbers that don't have any x's. I'll write those in blue. Here we have 3 plus 8, which is 11. And then we subtracted 1, which is 10. Now, if you look at the simplified expression and our original expression, there's this equal number of x's on both sides and the equal number of constants on both sides. both of these expressions are equal to each other. One just has the terms collected. I'm going to pop over to the whiteboard and we can try some examples. So I took the liberty here to write out what some of these terms would mean in almost like a picture form. For example, let's see here. Number 2 is 9a minus 10a. Well, here I wrote this a little bit differently, but you'll get the drift in a second. Here I have negative 9a plus 10a, and what I did is I actually wrote out what 9 negative a's would look like, and then I'm adding 10 positive a's. And we know from the identity property that we worked on that negative a plus a is just 0. So I'm going to take my black pen here, and every time I see a negative a and a positive a, I'm going to cross it out. Negative a, positive a. Negative a, positive a. Cross, 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 cross. And I'm going to cancel all of these a's. But notice I have one positive a left over. So that would mean that negative a plus 10a is equal to positive 1a. Let's try another example. 5h minus 6 minus 8 plus 7h. Remember, if you look over at your notes, the pattern that we're going to do is we're going to collect the terms that are similar to each other. So let's first collect the h's. Right here I see that we have 5 h's, and right here I see that we have positive 7 h's. So altogether, that's 12 h's. Right here I see we have negative 6, and right here we have negative 8. So altogether, that's negative 14. And now this expression has been simplified because the like terms have been collected. Let's try one more, but this now has some more variables. We have 26a plus 2b minus 4a plus 10b. Now I know we have two variables moving around, but that's okay. We're just going to keep asking ourselves, what are the like terms in this, and how do I collect them? So let's do the a's first. How many a's are in this expression right here? Well, there's 26 right here, and there's negative 4 right here. Well, 26a minus 4a is going to be positive 18a. Just like over in this example, how the negatives cancel out some of the positives. If we took away 4 negative a's and paired them with 4 positive a's, we'd have 18 a's left over. So now let's collect the b's. Let's do that in blue. Right here we have 2 b's, and right here we have positive 10 b's. So altogether we have 12 positive b's. So now this expression has been simplified from 26a plus 2b minus 4a plus 10b to just 18a's plus 12b's. The last stuff we're going to go over is when we combine like terms with terms that have different types of powers. I'm going to read this to you. Terms with the same exponents or combination of variables and exponents are considered like terms. When we combine these, be sure not to change their exponents. So let's look at number 9, and I'll write this one right on the page for you. Let's do it in green. We have 5x squared plus 7x squared. Well, how many x squareds do we have? Well, we have 5 here and 7 here. So altogether we have 12 x squareds. Not too bad when it's just all by himself. Let's try it a little bit harder problem. Let's look over here. Here we have a little bit of a longer expression. We have 4x squared minus 7 plus 2x minus 3x squared plus 8x minus 6. But don't you worry, we're just going to combine the like terms. First, let's do the x squares. How many x squares do we have? Well, we have 4x squares right here, and negative 3x squares right here, so altogether we're left with 1x squared left. In red, we're going to do the x's. Right here we have 2 x's, right here we have 8 x's, so altogether we have 10 x's. And last but not least are the constants. Right here we have negative 7, right here we have negative 6, altogether we have negative 13. Go ahead and work on some practice problems, and we'll sketch note this in class the following day. I'll see you guys in class.